Okay, question 5 from Nest 18, question 48. Integral minus 1 to 1 mod x upon 1 plus e raised to x dx. 0 1 upon 2 1 e minus 1 upon e. Okay, first question to you. Can option A be right?
No, sir.
No, A is not right. A cannot be right. Because for all values of x in the closed interval -1 to +1 except 0 f of x is positive. Okay, so A is not going to be right. Now let us decide whether it is B, C or D. How to decide that? Our obvious first step would be splitting the interval to -1 to 0, where mod x will be negative x, plus 0 to 1, where mod x will be x. Correct? Now after this, any suggestions from your side? What can be done? Yes, come on.
So King's rule
What is King's rule again?
is that property that will if
A plus B minus x.
yeah.
No. A plus B minus x. Hmm, we can use it. I think it gives you the same output as integration by substitution. So my take, we'll come back to that. My take is substitute x as negative t here. So dx would be negative dt. Okay, dx would be negative dt. And what will happen to the limits? X's limits are -1 and 0. So t's limits would be 1 to 0. Correct? So first integral transforms itself to what? After substitution. 1 to 0 t upon 1 plus e raised to negative t and dx is negative dt. Now flip the limits. Flip the limits using the negative sign. So we also use the property of definite integration there. And now we can add because we can add the integrands because the limits are same. Because the limits are same, we can add the integrands. Okay. So we get 0 to 1. Let's take, see again one more property we are using. We are using the fact that variable of integration is immaterial, right? Both these variables are dummy. Okay, they are dummy variables, so we can use x or t, whichever variable we want to continue. Okay, so we can keep it x. Is it clear now? Yes or no? Take x common, LCM. Take the product in the denominator, 1 plus e raised to minus x plus e raised to x plus, and everything fits so well, and that's very satisfying because all the terms getting cancelled here. The numerator is essentially the same as the denominator, so that gives you 1. Integral of 1 is x squared by 2. Answer is option B. Okay, now let's come to that King's rule according to you. Well, I didn't know that it was called King's rule. I just say a plus b minus x. But anyways, so you said a plus b minus x, use it for mod x. I think that will also work. Let's do it. So it's -1 to 0 a plus b minus x. No, I don't think that will work, because it will complicate things in rather, right?
Yes, sir, it's complicating the things. I thought
Yes,
it
yes.
will work, but
Even initially I thought that it might work because of negative 1 to 0, but what it turns out is limits are not changing. Limits are still negative 1 to 0, so that rule will not work. Okay, fine. So again, a live demonstration that it will, every property will not always give you to the, take you to the final answer. It will still give you something which you cannot do anything with that. Okay, let's verify it here. Let's verify it here. Integral minus 1 to 1 fraction mod x upon 1 plus e raised to x dx. Half, so that's verified. ठीक है, got the answer, understood how this MCQ was to be solved? Yes, no? Yes. Now let's come to that symmetry part. If you plot the graph of mod x upon 1 plus e raised to x, okay, the graph will look like this. Okay, the graph will look like this, and or let's say x upon this. Oh, sorry, mod x. Okay. Now, if I make the transformation x to negative t, and if I plot the graph of negative mod x upon 1 plus e raised to negative x, okay, it will be something like this. Now, although the graphs independently don't have any kind of symmetry, you realize that when we plot them together, they definitely exhibit some kind of symmetry. So the branch of the black curve in the first quadrant and the branch of the blue curve in the second quadrant, they are definitely mirror images of each other. You would agree to that. And same thing with the graph of the black colored graph in second and blue colored graph in first, which basically means that if we are to integrate mod of x upon 1 plus e raised to x, okay, from minus 1 to 1, what I can do is I can make use of two functions areas, one between 0 and 1 black and other between 0 and 1 blue. Do you agree to this? Think about it. Let's take this discussion there so that we can plot a few things and draw on the graph. Look, we essentially want the integral from minus 1 to 1, okay, minus 1 to 1, this one, okay. So it's basically this area and this area. Okay, but because of symmetry, I can say that the whole of the green area, is actually equal to whole of the red area. Raise your hands if you understand that. And that's exactly what we do when we split the integral into two. Okay, that's exactly what we do when we split the integral into two parts, right? Among them, the first part is essentially the blue area. Okay, first part is essentially the blue area, but the second part corresponds to the reflected red area. It's originally green, it is originally green, but because of its reflection about y-axis it became red or positive. Is it clear?